Hi everyone, I hope you all had a good weekend and got some rest and some exercise. So here's our next video for some more practice in balancing word equations. So if you remember from last week, the first thing you have to do is convert the word description of the compound into the chemical formula of the compound. Once you've got that, then we use the skills you learned a couple weeks ago about balancing equations. So let's start off with this one. You have solid aluminum oxide is decomposed into aluminum and oxygen. Now remember, when we were talking about types of chemical reactions, in a decomposition reaction, which is what this is, you start out with one compound and you break it down into more than one thing. So first, let's figure out the chemical formulas of the components. Now, aluminum, because of its position in the periodic table, we know is a +3 ion. And because you know your ions, you also know that oxide is a -2 ion. So we have an odd number and an even number. So when you have a 3 and a 2, you want to find the least common multiple of both, which is 6. Which means we're going to need 2 aluminums to get to +6, so it's going to be Al2, and you're going to need 3 oxygens to get to -6. So the formula for solid aluminum oxide is Al2O3, and we put a little subscript S in parentheses to indicate it's a solid. Now it's a decomposition reaction. Let's figure out what our products are. This is a little bit easier. Aluminum is just into aluminum, so Al, that's all there is to it. And unless I say otherwise in the reaction, assume the state of matter is what it would be at room temperature. And we all know that aluminum, last time I checked, is a solid at room temperature. Now, for oxygen, we have to follow the rule of 7s. Remember, we learned about that last semester. Oxygen is one of those 7 elements that in nature exist as a diatomic gas. So it's going to be O2, and we'll put the subscript G under that. So it becomes Al2O3 solid goes to Al solid plus O2 gas. So now we know what the formulas are. We're going to focus on balancing them. And we don't have any polyatomic ions here, so that's good. That makes it a little easier. But we have an odd number of oxygens here and an even number of oxygens here. So we're going to need to do something about the odd-even rule. So we're going to use the odd-even rule. Okay, so to make this odd number even, we need to put a 2 in front of the aluminum oxide. And if I do that, that's going to give us 4 aluminums on the left side, and 2 times 3 is 6 oxygens on the left side. And to get 6 oxygens over here, we're going to have to put a 3 in front of the O2. So that gives us 6 oxygens on the right side, so that's good. But now we need to balance our aluminums, and since we have 4 here, we've got aluminum all by itself. We just put a 4, and we're done. Okay, so you may wonder why I started with the aluminum using the odd-even rule, and with the oxygen using the odd-even rule instead of the aluminum, and that's because the aluminum looked more flexible. And what do I mean by that? Since there was no subscript on the aluminum on the right-hand side, I knew it would be easier to get the number of aluminum atoms we needed to balance this. So, it's kind of like there's a saying called eat the frog, which means you do the hard part first. And since you had subscripts on both of the locations where oxygen that means you probably should do that one first and get that out of the way. Okay? All right, let's move on to our next one. All right, so for our next one, we are going to do this. Now this one says, ammonia vapor and hydrogen sulfide gas react to produce solid ammonium sulfate. Okay, and to solve this one, you need to know that the formula for ammonia vapor is NH3 in a gas. Now, ammonia is a pretty common compound, so when we created this worksheet years ago, we kind of assumed that students knew ammonia was NH3, but I'm just telling you that in case you don't know that. Okay, so ammonia vapor is NH3 gas. Now, hydrogen sulfide gas, we know hydrogen forms a +1 ion. Okay, sulfide is S2 minus. So hydrogen sulfide has to be H2S gas. So on the reactant side, we're going to have NH3 gas plus H2S gas. And it says it reacts to form solid ammonium sulfide. Now ammonium, because we know our polyatomic ions, is NH4 plus 1. Sulfide, we know, is S2 minus. So ammonium sulfide is going to be NH4 in parentheses with the subscript 2 S, because we're going to need 2 of those ammonium ions to balance out the charge on that sulfide ion. Alrighty? Okay. Now that we've got the formulas down, let's work on balancing it. Okay? Now, you've got ammonium here, which gives me 2 nitrogens, but I only have 1 nitrogen on this side. So let's start by putting a 2 here. Alrighty? So let's count up how many atoms we have now on each side. So that 2 means we're going to have 2 nitrogens here. We're going to have, now let's look at our hydrogens. Our hydrogens, we're going to have 6 coming from our 2 ammonias, but we have another 2 here, which gives us 8. And for sulfurs, we have 1. All right? So let's take a look on the right-hand side. That 2 means we have 2 nitrogens. 2 times 4 is 8 hydrogens and 1 sulfur. So what do you know? That's actually kind of easier than I think it looks when you first look at the problem. All right. Let's do one more problem, and then when we're done with this last one, I want you to go to the website and try the practice problems that I posted under today's date and see how you do. And as always, if you have trouble with it, please send me an email and we can go through it. All right? All right, here we go. Lead, Roman numeral 2 sulfate, is precipitated from a mixture of water solutions of potassium sulfate and lead 2 nitrate. Now, precipitated from, this time the word equation is kind of written backwards. So what are we actually making in the sentence that describes this reaction? What we're actually making is the lead sulfate, because the lead sulfate is being precipitated from this mixture. So lead sulfate is actually our product. And in the problem, they're saying lead 2, so it's going to be Pb plus 2. Sulfate, we know because we memorized our ions, is SO4 2 minus. So the formula for lead sulfate is PbSO4. Okay, and it's saying it's precipitated from. Precipitated means that you start to see a powder crystallize at the bottom of the solution. So that's a solid. So that's our product. And it's coming from a mixture of water solutions of potassium sulfate and lead nitrate. Water solutions just means it's dissolved in water or aqueous. Okay, so let's look at potassium sulfate. Potassium is +1 due to its position in the periodic table. Sulfate, as we said before, is SO4 2 minus. So potassium sulfate is going to be K2SO4, and it's going to be AQ, which means aqueous, which means dissolved in water. All right, now let's look at our other reactant. Our other reactant is lead Roman numeral 2 nitrate, so it's going to be Pb2 plus. Nitrate, because we know our ions, is NO3 minus 1. So the formula for lead nitrate is going to be Pb parentheses NO3 with a subscript 2 next to it. Now you're probably looking at this saying, wait a minute, where did the potassium and the nitrate go? And the potassium and nitrate aren't specifically mentioned in this sentence, but you know, we can't create or destroy matter. That's what the physicists do. We don't do that in chemistry. So that potassium and that nitrate, what's implied is that they form a compound together. Now, since we know potassium is +1 and nitrate is -1, the second product in this reaction is going to be KNO3. Okay, because the charges balance out. So we have two reactants, K2SO4 and PB parentheses NO3 parentheses 2, forming PbSO4 and KNO3. All right. Now, let's balance it. And you can't break up that nitrate. And since we have two of them here, let's start by putting a 2 in front of the potassium nitrate on the right-hand side of the equation. Okay, now let's count up and see what we have. On the left side, we have 2 potassiums, we have 1 sulfate ion, we have 1 lead, and we have 2 nitrate ions. Now over here we have 1 lead, we have 1 sulfate, we have 2 potassiums, and 2 nitrates. And we're done. We're balanced. And this is pretty much as bad as it's going to get in this class for changing these word equations or sentences into chemical equations. The key things that make this one kind of tricky is that you need to understand that if something's being precipitated from, it's kind of like the sentence is written backwards from the way the chemical equation goes. That's how we knew lead sulfate was the product. And then the other product in this one was not explicitly stated. So basically what you do is you take what you have left over in your reactants, which in this case was a potassium ion and a nitrate ion, and make the most sensible equation, most sensible compound from what you had left. Alrighty, so that's it for today. Stay healthy and enjoy your day. Bye.